Hi, in this video I'm going to talk about some of the popular data science algorithms that most data science use in their daily activities. The first one is the OLS, or we call it as ordinary least square regression, and in short we call it OLS, which stands for ordinary least square. So this is a regression algorithm which is used to fit a linear line to the regression to your data set. Okay. So say for instance you have a variable, a target variable y, which is continuous in nature, and it depends on a factor x. So if you plot it in x and y z plane, x1 y plane, and just fit a regression line which is given by y equal to beta naught plus beta 1 x, where beta naught and beta 1 are the estimates. We call that as a regression line fit. Okay, and this can be used for two purposes. Okay, one is for forecasting purpose, so you can forecast to for the future. So that's one purpose of fitting a regression line. The second one is to quantify the marginal effect. Okay, so what is marginal effect? It's like if you increase x by some amount, what is going to be the corresponding increase in y? That's marginal effect. Okay, so you do that with taking the first derivative of your target variable. The next algorithm is the decision tree. It's a popular algorithm. It's a binary classifier which is used to choose one from the given decisions that using the features that you have been given. So just to give you an example, you have got a target variable y which depends on x1, x2, x3 and so on. Okay, and this is a binary variable, like it has got 0 and 1. So based on the value of x1 and x2 and x3, you just have to you are required to select the value of y to be 0 or 1. So it's a binary classifier. So using decision tree you can actually find that out. Okay, so a decision tree, when you visualize, it looks something like this. Okay, based on some criteria on x1, x2 and x3, which are the features, you either select it as y to be 0 or 1, which could take any values. Okay, any binary values. Okay, the next one is the naive Bayesian classification or classifier. So this uses the Bayesian's theorem. If you're not familiar with Bayesian theorem, so this is the one which is the Bayesian theorem. You're trying to find out the probability of event A happening given event B. Okay, and it uses strong independent assumptions of features. So whatever features you are using in your data, it assumes that there is strong independence. There is no dependency between the features. It's very popular in text mining and in classifying your email to be spam or normal emails. So it's a popular algorithm used in text mining or text analytics. The next one is the logistic regression. It's a popular algorithms and it's very simple to use. It's also an algorithm to classify data into two groups or multiple groups. So it's primarily used for binary classification or binomial target variable. That means which takes value of 2 and can be extended to multinomial. Okay, so it can take 0, 1, 2, 3. They're like 4 classes. So we call that as multinomial logistic regression, which is an extension of logistic regression. It's simple and it's linear in nature. The computation time is much less compared to some of the more complicated classification algorithms. It's popular in credit scoring, in risk analytics in banking and financial service company, also in insurance companies. It's also heavily used in marketing campaign analytics. The form that it takes is like this. You try to model the log the log odd, using a linear combination of your features. Okay. The next one is the SVM, or known as the support vector machine. So in this type of this particular type of algorithm uses hyperplanes to separate binary classes. So instead of a linear line, it actually uses hyperplanes, multiple ones, to separate data, and hence the separation is more efficient in this case, because it takes into consideration the non-linearity in the data, which often gets ignored in simple classification algorithms like logistic regression, where it's always assumed that there is linearity, and it's very highly scalable, so it can be used for very large data set. Even though there is a consideration of non-linearity, there is a multiple hyperplanes being used for classification. One would expect a lot of time for computation, but it is highly scalable in that sense. The next one is the clustering algorithms. Clustering algorithms, like so far what we have seen, can be considered as supervised learning algorithm, right? Supervised algorithm, because you have a target variable in whatever algorithm that we learned so far. But for clustering algorithms, this is purely an unsupervised learning algorithm, which doesn't use a target variable for classification. So what it does is it groups objects into different types. Okay, the similar objects to be one type. If you can see in the picture, you can see the cross marks of different colors. So in a clustering algorithm will do what? It's going to group the similar looking data points or maybe variables. Okay. So it does classification where there is no target variables. Okay, and that's important to note here. And it is used for dimension reduction, and it's also used for segmentation purpose. The next one is the PCA, or the principal component analysis. Okay, so PCA is used for a number of purposes. It's primarily used for dimension reduction, where you want to get down to a few number of variables from a large set of variables. Okay, so what it does is it takes the orthogonal transformation of correlated variables to convert a number of correlated variable to a small number of uncorrelated principal components. So the data set actually changed, but the information remains the same. Okay, so it does some kind of a data transformation so as to ensure that a large set of variables which are supposed to be very correlated get down to a smaller set of variables which are totally uncorrelated. But by the way, the transformed variables are totally different from the previous variables. Okay, so it takes some kind of a linear combination of variables to come up with the new variables, but the information remains almost same. It's also used for regression purpose, so we call that as principal component regression. So what it does is it first uses PCA to reduce the number of features, and then it uses linear regression, which is known as PC principal component regression. The next one is the linear discriminant analysis. It's used for classification of classes. It's first used by Ronald Fisher, and one of the famous experiment that he made is on classifying flowers. Okay, and he has got a very that example has been cited many times for classification purposes. So it is used for classifying two or more linear combination of features, and it actually is a competitor to the linear regression, logistic regression. So logistic regression is also another classification technique, and LDA, or linear discriminant analysis, is also considered to be another good classification technique, and it's heavily used in marketing science and also used in medical science research, where medical scientists use for pattern recognition in the medical data. Thank you so much, and please subscribe to our channel, and please also contact us for anything you need.